Part 1. The Origins of Asteroids, A Journey Through Time. The story of asteroids begins long before they became a potential threat to Earth. In fact, their origins trace back to the very beginning of our solar system. Billions of years ago, the Sun was just beginning to form, and the surrounding space was filled with swirling gas and dust. This cloud of material eventually began to condense, clumping together to form planets, moons, and other celestial bodies. But not everything that formed from this cosmic dust became a planet or moon. Some of these leftover remnants, too small and too scattered, failed to become planets. These objects, drifting through space, became known as asteroids. Asteroids are rocky bodies that orbit the Sun, and they can vary greatly in size. While some may be as small as a pebble, others can stretch for hundreds of kilometers. These rocky remnants are often considered to be frozen in time, preserving the conditions of our early solar system. They are like ancient fossils, holding the secrets of the formation of our solar system. Scientists believe that the majority of asteroids reside in what is known as the asteroid belt. This region lies between the orbits of Mars and Jupiter. The asteroid belt is not a dense field of rocks, as many people imagine, but rather a vast, sparse area where asteroids are scattered far apart from one another. But how did these asteroids come to be? The asteroid belt in particular is thought to be the result of a failed planet. During the early days of our solar system, the gravity of the massive planet Jupiter disrupted the formation of a planet in this region. As Jupiter's gravity prevented the formation of a large planetary body, the material that would have made up this planet instead formed into smaller asteroids. These asteroids have been orbiting the Sun for billions of years, some of them remaining largely unchanged. Over time, they've collided with one another, broken apart, and even been captured by the gravity of planets and moons. As they continue to orbit the Sun, they are constantly being shaped by gravitational forces, collisions, and the cosmic environment. But despite their ancient origins, asteroids are far from static. Their orbits can change over time, influenced by the gravitational pull of planets and the interactions they have with one another. Some asteroids may even find their way out of the asteroid belt and venture closer to the inner solar system where Earth resides. So, are asteroids a potential threat to Earth? Could one of these ancient bodies collide with our planet? Let's explore the answer to that question by first understanding the different types of asteroids and how their orbits are affected by the forces around them. Part 2. The types of asteroids and their orbits. Asteroids come in many shapes, sizes, and types. Understanding these differences is key to assessing the risks they pose to Earth. There are three primary types of asteroids: carbonaceous, silicate, and metallic. Each of these types has distinct characteristics, and their composition plays a significant role in determining how they behave in space. Carbonaceous asteroids or C-type asteroids are the most common type, making up around 75% of known asteroids. These asteroids are rich in carbon and organic compounds, which makes them dark in appearance. Their surface reflects very little sunlight, absorbing most of the light that hits them. These asteroids are thought to be some of the oldest objects in the solar system, and studying them helps scientists learn more about the conditions that existed in the early solar system. Next, we have silicate asteroids, or S-type asteroids. These are made primarily of silicate materials, such as silicate rock and metals like iron and nickel. S-type asteroids are relatively brighter than carbonaceous asteroids, reflecting more light. These asteroids are often found in the inner regions of the solar system, closer to the orbit of Mars. Their composition suggests that they were formed from material that was closer to the Sun, where higher temperatures caused certain elements to undergo chemical changes. Finally, there are metallic asteroids, or M-type asteroids. These asteroids are made mostly of metals, particularly iron and nickel, and they are much rarer than the other types. M-type asteroids often have a metallic shine, making them easier to spot with telescopes. These asteroids are believed to be the remnants of the cores of ancient larger planetary bodies that were shattered by collisions long ago. Their composition makes them an interesting target for future space missions, as they could contain valuable resources. But understanding the types of asteroids is only part of the picture. To truly assess the threat these objects might pose to Earth, we need to understand their orbits. Asteroids, like all objects in the solar system, travel along elliptical orbits around the Sun. Most asteroids remain in the asteroid belt between Mars and Jupiter, but some can be nudged out of their orbits due to gravitational interactions with other planets. This can cause them to drift into the inner solar system, where Earth resides. There are two main categories of asteroids that could potentially pose a risk to our planet: near-Earth asteroids (NEAs) and potentially hazardous asteroids (PH). Near-Earth asteroids are those that come close to Earth's orbit, crossing its path as they orbit the Sun. While not all NEAs are dangerous, they do pose a potential risk simply because their orbits bring them into proximity with our planet. These asteroids can vary in size, from small objects only a few meters across to massive bodies several kilometers in diameter. Scientists are constantly monitoring the paths of these asteroids to track their movements and assess any potential future threats. Within the category of NEAs, there is a subset of asteroids known as potentially hazardous asteroids (PH). PHAs are defined as asteroids that have orbits that bring them within 7.5 million kilometers, about 4.6 million miles of Earth's orbit, and are large enough to cause significant damage if they were to collide with our planet. These asteroids are closely watched by astronomers who track their movements to ensure that we are aware of any potential future impact events. One of the most famous near-Earth asteroids is Apophis, a large asteroid that was once considered a potential threat to Earth. Discovered in 2004, Apophis raised concerns due to its relatively close approach to Earth. Initially, calculations suggested a small chance that the asteroid could collide with Earth in the future. However, after further observation and more accurate measurements, scientists revised their predictions, and Apophis is no longer considered a significant threat. This example highlights the importance of constant monitoring and updated calculations when assessing the risk posed by these objects. As we continue to learn more about asteroids, astronomers are also working on ways to track their orbits with greater precision. By using powerful telescopes and radar technology, scientists are able to monitor the movement of asteroids in real time. This allows them to predict their paths and make more accurate assessments of any potential risk to Earth. Part 3: The Potential Threat. Could an asteroid hit Earth? Now that we understand the types of asteroids and their orbits, it's time to address the big question: could an asteroid actually hit Earth? The idea of a catastrophic asteroid impact can be both fascinating and frightening. After all, the Earth has experienced asteroid impacts before, with some events leaving a lasting mark on the planet's history. Asteroid impacts have shaped the course of life on Earth. One of the most famous impact events is believed to have contributed to the extinction of the dinosaurs about 66 million years ago. This impact, known as the Chicxulub event, left behind a massive crater in what is now Mexico. The collision caused fires, tsunamis, and a dramatic shift in the planet's climate, which led to the extinction of approximately 75% of life on Earth. This event serves as a stark reminder that asteroid impacts can have serious consequences. However, while catastrophic asteroid impacts are possible, they are extremely rare. The chances of a large asteroid hitting Earth in any given year are very low. The vast majority of asteroids in our solar system are far from our planet, and most of them follow stable orbits that keep them far away from Earth's path. Still, the potential threat is real enough that scientists have taken steps to monitor and track asteroids that could pose a risk. With the help of powerful telescopes and space missions, astronomers are constantly searching for new asteroids and tracking the orbits of known ones. This is important because while the chance of a major impact is low, it's not zero. Understanding the movement of asteroids and identifying potential threats is crucial for protecting our planet. Asteroid impacts are categorized based on the size of the object and the level of damage they could cause. Small asteroids less than 25 meters in diameter burn up in Earth's atmosphere and usually don't cause any harm. In fact, small meteoroids hit Earth's atmosphere every day, creating spectacular fireballs that we see as shooting stars. These objects are harmless, as they burn up before they reach the ground. Medium-sized asteroids between 25 and 140 meters in diameter are capable of causing significant damage if they were to strike Earth. While an asteroid of this size might not cause a global catastrophe, it could create massive local destruction, including a powerful explosion and widespread fires. The 2013 Chelyabinsk event in Russia is a perfect example. A meteor exploded in the atmosphere over the city, causing extensive damage to buildings and injuring over 1,500 people. Thankfully, this event was not as deadly as it could have been, but it serves as a reminder that medium-sized asteroids can be a real threat. Large asteroids greater than 140 meters in diameter have the potential to cause global devastation. These are the objects that could have long-lasting effects on the planet, similar to the Chicxulub impact. A large asteroid impact could cause widespread fires, tsunamis, and even trigger a dramatic change in Earth's climate. The effects could last for years, possibly even causing a mass extinction event. But how can we predict if an asteroid will hit Earth? This is where technology plays a crucial role. By using advanced telescopes and radar, scientists are able to track the orbits of asteroids and monitor any potential changes. They measure the position of an asteroid in the sky with incredible accuracy, allowing them to calculate its future trajectory. If an asteroid is found to be on a collision course with Earth, scientists can predict the time and location of the impact. In addition to monitoring, scientists are exploring ways to prevent a potential impact. One idea is to use a technique called asteroid deflection. This involves changing the trajectory of an asteroid so that it no longer poses a threat to Earth. There are several methods being considered, including using a spacecraft to collide with the asteroid and change its course, or using a spacecraft to slowly pull the asteroid off course, using a technique called gravity tractor. Though deflection technology is still in the early stages, it's an area of active research, and some space agencies such as NASA are already conducting experiments to see how we might be able to protect Earth from future asteroid threats. While the risk of an asteroid impact remains low, it's important to continue monitoring and researching these cosmic objects. The more we understand about asteroids, the better prepared we will be if a potential threat arises. Part 4. How close are we to preventing an asteroid impact? Now that we've covered the basics of asteroid threats, let's dive into the efforts scientists are making to prevent an asteroid from hitting Earth. As we've seen, the likelihood of a large asteroid colliding with Earth is low, but the consequences of such an impact would be catastrophic. This makes it vital for scientists to be proactive and develop strategies to detect, monitor, and if necessary, deflect asteroids that pose a risk. As we've discussed, the primary method to protect Earth from asteroid impacts is by tracking the orbits of these objects. Space agencies like NASA, the European Space Agency, ESA, and others are constantly observing the sky, looking for new asteroids and monitoring the paths of known ones. Telescopes around the world and in space, such as the Pan-STARRS and NEO-WISE telescopes, are on the lookout for near-Earth asteroids, NEAs, and potentially hazardous asteroids, PHAs, that might be headed our way. These telescopes use a technique called sky surveys to scan the sky for moving objects. When an asteroid is spotted, its orbit is carefully calculated, and astronomers track it over time to predict its future path. The goal is to identify any objects that could pose a threat to Earth, sometimes years or even decades in advance. But what happens when a potential asteroid impact is detected? Fortunately, there's still time for action. If an asteroid is identified as a possible threat, scientists can use advanced tools and techniques to study its size, composition, and orbit in greater detail. This allows them to better understand how dangerous the object might be and whether it's truly on a collision course with Earth. One of the most exciting advancements in asteroid tracking is the use of radar. Radar systems can bounce signals off asteroids, allowing scientists to determine their precise position, speed, and rotation. This helps create more accurate models of their orbits and can be critical for predicting potential impacts. The more data we have, the better we can understand the risk and make decisions on how to proceed. While monitoring asteroids is critical, what about deflecting them if they're on a collision course with Earth? As we discussed earlier, there are several potential methods for asteroid deflection, and scientists are actively testing these ideas. One of the most promising methods is kinetic impact, where a spacecraft is sent to collide with an asteroid at high speed. The force of the impact would change the asteroid's trajectory, nudging it off course. NASA's Double Asteroid Redirection Test DART mission, launched in 2021, is the first real-world test of this technique. The DART spacecraft successfully crashed into an asteroid named Didymoon, part of a binary asteroid system, to see if it could alter the asteroid's orbit. Early results suggest that the method could work, offering hope for future asteroid deflection missions. Another approach being explored is the gravity tractor method. In this technique, a spacecraft would hover near the asteroid and use its gravitational pull to gently nudge the asteroid off course over time. While this method would require more time to be effective, it has the advantage of being more controlled and precise. The challenge, however, is that it would take years or even decades for a gravity tractor to make a significant change in an asteroid's path. In some cases, scientists have even proposed using a nuclear explosion to divert an asteroid. The idea would be to detonate a nuclear device near the asteroid, not to destroy it, but to use the energy from the explosion to push the asteroid off course. While this method could be effective, it would likely be a last resort, as the use of nuclear weapons in space would come with significant political, technical, and safety challenges. While deflection methods are still in the experimental phase, they are an important part of our asteroid defense strategy. The hope is that as technology advances and our understanding of asteroids improves, we will be able to develop effective tools to protect Earth from potential impacts. The good news is that for now, we are not facing an immediate asteroid threat. Thanks to the work of astronomers and space agencies around the world, we have a better understanding of the risks and are making progress toward developing ways to protect our planet. With ongoing research and collaboration, we'll be better prepared if the need ever arises. Part 5. The Future of Asteroid Exploration. While we focused primarily on the potential risks and defense strategies for asteroids, another crucial aspect of understanding these space rocks is exploring them. Asteroid exploration has the potential to unlock valuable scientific discoveries and even benefit humanity in unexpected ways. One of the key reasons for studying asteroids is that they are considered the building blocks of the solar system. Most of the material in our solar system that didn't form planets, moons, or other bodies is likely found in asteroids. By studying these objects, scientists can learn more about the early solar system, how planets formed, and even the origins of water and organic compounds on Earth. In essence, asteroids could hold the keys to understanding our cosmic origins. In recent years, space missions have been launched to visit and explore these distant objects. NASA's OSIRIS-REx mission, which launched in 2016, traveled to the asteroid Bennu, one of the most dangerous near-Earth asteroids. The spacecraft arrived at Bennu in 2018 and spent several years studying its surface, composition, and orbit. In 2020, OSIRIS-REx successfully collected a sample from Bennu's surface with the goal of returning it to Earth in 2023. This sample could provide valuable insights into the building blocks of our solar system and the potential resources that asteroids might contain. Japan's Hayabusa 2 mission, which arrived at the asteroid Ryugu in 2018, is another remarkable example of asteroid exploration. Hayabusa 2 collected samples from Ryugu, which were returned to Earth in 2020. By studying these samples, scientists hope to learn more about the materials that could have contributed to the formation of life on Earth, such as amino acids and other organic molecules. Asteroids could also play a major role in the future of space exploration. As space travel becomes more advanced, asteroids could become sources of valuable resources such as metals, water, and other raw materials. The concept of asteroid mining, although still in its early stages, holds great promise. The idea is that asteroids, which are rich in resources, could be mined from materials like platinum, gold, and rare metals, which are essential for building spacecraft, satellites, and even supporting life in space. Water is another valuable resource that could be extracted from asteroids. Water is essential for life, but it also has practical applications in space. It could be converted into oxygen for breathing and hydrogen for fuel. Mining asteroids for water and other resources could provide a sustainable way to support future space missions, including long-duration missions to the Moon, Mars, and beyond. In fact, NASA and other space agencies have already begun to explore the potential for asteroid mining. In 2018, NASA's Planetary Resources Initiative, in collaboration with private companies, began developing technologies to explore and mine asteroids. Though asteroid mining is still far from being a reality, the potential to tap into the wealth of resources in space is an exciting prospect for the future. Looking further ahead, asteroid exploration could open the door to the colonization of other planets. As humanity pushes further into space, establishing a presence on the Moon and Mars, the resources we find in asteroids could play a crucial role in supporting human life on these distant worlds. Whether it's extracting water for life support or mining metals for construction, asteroids could provide the raw materials necessary to establish thriving colonies beyond Earth. In the coming decades, asteroid exploration will likely become an increasingly important part of our efforts to understand the universe and expand humanity's reach into space. Missions like OSIRIS-REx and Hayabusa 2 are just the beginning, and with advancements in technology, the potential for discovering new knowledge about asteroids and their resources is vast. As we continue to explore the cosmos, the question of whether we can harness the resources of asteroids and use them to support human life beyond Earth will be crucial. By learning about these space rocks and understanding how they might shape the future of space exploration, we are taking the first steps toward a new era in human history, one where the universe becomes more accessible and the possibilities for life beyond Earth grow ever more exciting. Part 6: The Role of Asteroids in Understanding Life's Origins Beyond the Threat of Asteroid Impacts. Asteroids hold another crucial key: the potential link between these space rocks and the origins of life on Earth. Scientists have long speculated that asteroids may have played a role in delivering the ingredients necessary for life to emerge on our planet. One of the most intriguing ideas is the possibility that asteroids carried water to Earth. During the early days of the solar system, the Earth was a hot, hostile environment, and the presence of liquid water would have been unlikely. However, scientists believe that asteroids, particularly carbon-rich ones, could have bombarded Earth during a period called the Late Heavy Bombardment, between 4.1 and 3.8 billion years ago. These impacts could have brought water to the young Earth, helping to create the conditions for life. In addition to water, asteroids may have also delivered key organic molecules, such as amino acids. Amino acids are the building blocks of proteins, which are essential for life. Interestingly, amino acids have been found in some asteroids, such as the one studied by NASA's OSIRIS-REx mission and Japan's Hayabusa 2 mission. These findings suggest that asteroids could have been responsible for providing some of the crucial ingredients for life's early stages on Earth. Scientists are also studying the potential for asteroids to contain other vital organic compounds, such as nucleobases, which are the components of DNA and RNA. The discovery of these compounds in asteroids would be groundbreaking because it could mean that life's building blocks were widespread throughout the early solar system. This would imply that the emergence of life on Earth may not have been a unique event, but rather a common process in the universe. In recent years, missions like OSIRIS-REx and Hayabusa 2 have returned samples from asteroids to Earth, which are currently being analyzed in laboratories. These samples could reveal important information about the types of organic compounds present in asteroids and whether they are similar to the compounds that make up life on Earth. Understanding the composition of these space rocks is a key part of answering the question, did asteroids contribute to the origin of life on Earth? This line of research has broader implications for the search for life beyond Earth. If asteroids carried the building blocks of life to Earth, then it's possible that similar objects could have played a role in the development of life elsewhere in the universe. This idea supports the theory of panspermia, which suggests that life on Earth may have originated from microorganisms or chemical compounds that were transported to Earth from space. If asteroids were involved in this process, it raises the exciting possibility that life could exist elsewhere in the universe, waiting to be discovered. In addition to providing essential materials for life's origins,
Asteroids could also help us understand the process of planetary formation. Studying asteroids allows scientists to learn more about the conditions and materials present in the early solar system before planets and moons formed. By understanding how these ancient rocks were formed, scientists can gain insights into how Earth and other planets came into being. Asteroids are time capsules, preserving remnants of the early solar system that have remained largely unchanged for billions of years. Unlike planets, which have been shaped by geological processes, asteroids have experienced little to no alteration, making them perfect objects for studying the early solar system. By examining the chemical composition and structure of asteroids, scientists can reconstruct the conditions that led to the formation of the Earth and its neighboring planets. The study of asteroids also helps scientists understand the broader processes that govern planetary systems. For instance, asteroids can reveal information about the migration of planets, the distribution of material in the solar system, and the factors that influence planetary habitability. Understanding these processes is crucial as we continue to explore exoplanets and search for other habitable worlds beyond our solar system. Through asteroids exploration, we are piecing together the puzzle of our solar system's origins and the origins of life itself. Every asteroid mission brings us closer to understanding how life on Earth began and whether life might exist elsewhere in the universe. As we learn more about these fascinating objects, we are also expanding our knowledge of the universe and the possibilities that lie beyond our planet.
Part 8. The future of asteroid mining. In addition to the threat that asteroids pose to Earth, there is also the incredible potential they hold for benefiting humanity. Over the past few decades, asteroid mining has become a hot topic in the space industry, as these space rocks are thought to contain vast amounts of valuable resources. Could asteroids provide the materials needed for future space exploration, or even help alleviate some of Earth's resource shortages? Asteroids are rich in a variety of metals and minerals that are essential for modern technology. Gold, platinum, nickel, and iron are just a few examples of valuable materials that are believed to be abundant in certain asteroids. These metals are often rare and expensive to mine on Earth, but they could be much more accessible in space. For example, the asteroid 243 Ida, which is located in the asteroid belt, contains vast amounts of nickel and iron, while the asteroid 5112 Tsinghua is rich in platinum group metals. The prospect of asteroid mining has the potential to revolutionize industries on Earth. Platinum, for instance, is used in everything from electronics to catalytic converters, and it's notoriously scarce on our planet. If we could mine platinum from asteroids, it could significantly reduce its cost and create new opportunities for industries that rely on this rare metal. Similarly, other metals and resources found in asteroids could be used to manufacture spacecraft, build space habitats, and support the growing demands of a future space economy. Beyond the resources that asteroids could provide, asteroid mining could play a crucial role in the exploration of the solar system. As humanity begins to establish permanent settlements on the Moon and Mars, we will need resources to build infrastructure, sustain life, and power future missions. Asteroids, with their abundant resources, could be the key to making space exploration more sustainable. In the not-too-distant future, companies like Planetary Resources and Deep Space Industries are planning to send spacecraft to mine asteroids for their valuable resources. While asteroid mining is still in the early stages, advancements in robotics, spacecraft technology, and resource extraction techniques could soon make this endeavor a reality. If successful, asteroid mining could create a new space economy, providing the materials needed for space stations, lunar bases, and even interplanetary travel. However, asteroid mining does present significant challenges. For one, it's difficult to predict the composition of an asteroid before we send a spacecraft to mine it. We would need to develop sophisticated systems to analyze asteroids remotely and determine whether they contain the materials we're hoping to extract. Additionally, mining in space presents a host of technical hurdles, such as how to extract and transport resources from asteroids to Earth or other space stations. Despite these challenges, asteroid mining remains one of the most exciting prospects for the future of space exploration. With the right technology and international cooperation, we could see a time when asteroids are not only viewed as potential threats, but also as valuable resources that support humanity's expansion into the cosmos. Part 9. The role of asteroids in our understanding of the solar system. As we've explored, asteroids are much more than just space rocks. They provide valuable insight into the early days of the solar system and offer clues about the formation of planets, moons, and even the potential for life. By studying asteroids, scientists are able to piece together the history of our cosmic neighborhood and gain a deeper understanding of how our solar system came to be. Asteroids are remnants from the early solar system, and they are often referred to as building blocks of the planets. Unlike planets and moons, which have been shaped by geological processes like erosion, tectonic activity, and volcanism, asteroids have largely remained unchanged for billions of years. This makes them incredibly valuable as time capsules that preserve information about the conditions that existed in the solar system when it was first forming. For example, asteroids can help scientists understand the distribution of elements and materials in the early solar system. By studying the composition of asteroids, we can learn about the types of materials that were present during the formation of the planets. This information can help explain why Earth has the elements necessary for life, while other planets like Mars or Venus are inhospitable. Asteroids can also teach us about the dynamics of the early solar system. During the formation of the planets, there was a period of intense bombardment, known as the Late Heavy Bombardment, which lasted from about 4.1 to 3.8 billion years ago. During this time, asteroids and comets collided with the young Earth and other planets, shaping their surfaces and possibly delivering the water and organic molecules needed for life. By studying the craters on planets and moons, scientists can piece together the timeline of these impacts and learn more about the violent processes that shaped the early solar system. In recent years, space missions have provided us with a wealth of data about asteroids. NASA's OSIRIS-REx mission, which recently returned samples from the asteroid Bennu, is one such mission that is helping us better understand the composition and history of asteroids. These samples will provide valuable information about the building blocks of the solar system and could help answer questions about the origins of life on Earth. By studying asteroids, we also gain insight into the potential for space exploration. Understanding the composition of asteroids and their potential for mining could help us develop the technology needed to explore and utilize these space rocks. This knowledge could also help us assess the risk posed by asteroids and develop strategies to mitigate the threat of an impact. Part 10. Asteroids, a cosmic mystery with endless possibilities. As we conclude our exploration of asteroids, one thing is clear: these space rocks are much more than just celestial objects floating in space. They are key to understanding the early history of our solar system, the origins of life, and even the future of space exploration. Whether as potential threats, sources of valuable resources, or time capsules from the past, asteroids have captured our imagination and our curiosity. While the possibility of a catastrophic asteroid impact is a concern, the progress we've made in tracking and potentially deflecting these objects is promising. With further advancements in technology, humanity may one day be able to protect itself from asteroid collisions, and we could even turn these space rocks into valuable resources that help sustain our exploration of the cosmos. At the same time, asteroids continue to offer us a window into the distant past, providing critical clues about how our solar system formed and how life began on Earth. As missions like OSIRIS-REx and Hayabusa 2 continue to return data from asteroids, we are getting closer to answering some of the most profound questions about our place in the universe. In the end, asteroids remind us that space is a vast and mysterious frontier, full of both dangers and possibilities. As we continue to explore, study, and learn from these ancient objects, we may discover that the answers to the greatest questions of life, the universe, and everything could be found in the smallest of cosmic rocks.